Hello class, today we are going to talk about two-column proofs. And I'll be honest, a lot of you will find this to be one of the more difficult things we do this year. But that's okay. So we're going to start off, before we get into the proofs, we're going to talk real quickly about some triangles. Again, we're going to use a lot of this stuff. So I have two triangles. I have this triangle and that triangle. Real quickly, are these triangles congruent? Yes, they are. Remember, we need three things for it. We have three things. We have one pair of sides, two pairs of sides, three pairs of sides. So these are congruent by side, side, side. So side, 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 congruence. Now, one thing I do want to talk about is how am I going to name this triangle to say that it's congruent to that triangle? Okay, I don't know if I said this in a previous video, so we're going to do it again. Real quickly, when we name these, if I have triangle ABC, I can't just say it's congruent to triangle DEF, okay? Because when we're naming congruent triangles or polygons of any kind, the angles that are congruent need to be in the same order. So A is congruent to F, so that means F needs to go first. B is congruent to E, C is congruent to D, and so I need to call this triangle FED, okay? Also, and don't think I said this in the last video, but real quickly, let me ask you, if I told you that segment AB had a length of 5 inches, how long would segment FE be? Well, if the triangles are congruent, that's pretty obvious. If this one's 5 inches, this one is also 5 inches, all right? Because they're congruent to each other, right? They're congruent. The triangles are congruent. The triangles are congruent, so the sides are congruent. Of course, these sides are already marked congruent, so that's one thing. But if two shapes are congruent, then not only are the sides congruent, like these are, but also the angles are congruent, aren't they? Everything's congruent. Sides are congruent, angles are congruent, everything's congruent. So if I told you angle A was 78 degrees, then angle F would also have to be 78 degrees. All right. This is a very useful little concept. What this is, we can say here, is that corresponding parts of congruent triangles are congruent. Now, when we're doing proofs, we have to write out everything. Just back it up with a reason. So, for example, here I said triangle ABC was congruent to triangle FED because of side, side, side congruence, right? Well, corresponding parts of congruent triangles are congruent. That is really long to write, and so we are not going to write that every time. We are going to abbreviate that simply as CPCTC. All right, so when we're doing our proofs, if we have, hey, I know this angle is congruent to that angle, it's because the corresponding parts of the congruent triangles are congruent. We're just going to say CPCTC. All right. Okay, so I am going to come over here and pull this up. Here we go. So here we go. I am given some information about the shape here. I am given that segment BD bisects segment AC. I am also told that segment BD is perpendicular to segment AC. I want to prove that these two triangles are congruent. Triangle ABE, which is this little triangle here, is congruent to triangle CBE. Where's CBE? CBE is this triangle here. Okay? So, now I'm doing this. Let's see here. So I know that those two bisect each other, and I know that those two lines are perpendicular. All right? Now, I'm doing this. They're giving me the statements. All I have to do is come up with the reasons. Okay, so first they're telling me, hey, you know what? That's a right angle. How do I know that angle AEB is a right angle right there? What was said up before that proves it? Well, that's what perpendicular means. Remember, this upside down T, that means perpendicular. Perpendicular lines, that makes a right angle. So let's see, what's over here? There we go. Perpendicular lines form a right angle. All right. Okay, so I want to prove that the triangles are congruent, these two triangles, right? In order to prove triangles are congruent, I have to have three things, remember? One of those has to be a side. Now, I've got that this is perpendicular, so those are both right angles. That's a right angle. Now I'm going to say that this is a right angle, because that's going to give me my angles are congruent. Because if they're both right angles, then right angles are congruent to each other. So I can do that. Let's see here. So I've got another perpendicular line. And now I can say that they're congruent because all right angles are congruent. Where is that? All right angles. There we go. All right angles are congruent. Boom. Alright, so now I have one set of congruent angles. I want to say that these sides are congruent. Alright, these right here. I want to say those are congruent. what has been said already up here that lets me know that these two sides are congruent to each other? Well, the only other thing we haven't used right here is that segment BD bisects segment AC. Alright, so if BD bisects AC, that means it cuts it in half, perfectly in half, so whatever's on one side is the same as the other side. So that's what we're going to use here. We have segment bisectors. So let's see, we've got something about segment bisectors. There we go. Segment bisector divides a segment into two congruent segments. Now the next thing we have, we're going to say, you know what? Segment BE is congruent to segment BE. That makes pretty good sense, right? Something's congruent to itself. Let's see, hopefully you remember what that property is called. That is the reflexive property, because you are congruent to your reflection, unless you're looking in the cloud mirror. But the reflexive property, something is congruent to itself. Anything is. Angles are congruent to themselves, segments are congruent to themselves, triangles are congruent to themselves, everything is congruent to itself. So now I have three things, right? I have one side, two sides, and an angle. And very important, notice that that angle there is in between the two sides, right? If that angle is not in between the two sides, we've got a problem. But the angle is in between the two sides, so our triangles are congruent. And that would be side, angle, side, because the angle is in between the sides. Right there. All right, so now we hit submit, and it says, yay, you did it right. Okay, let's go ahead and do another one. Let's do another one. Let's get some random problem here, see what it says. What do we got? Okay, so this one, we got a bit more complicated problem. There we got. So triangle ABC is congruent to triangle ADC. So let's see which two of those. That's okay. So that's the two big triangles, the big triangle on the top and the big triangle on the bottom. Tells us that triangle EBC is congruent to triangle FDC. That would be those two. Okay, so I know the whole big thing's congruent. I know that's congruent. I want to prove that AB is congruent to segment. Sorry, what do I want to prove? I want to prove that the little triangle is AEC. I want to prove that this triangle is congruent to that triangle. Well, in order to do that, I have to have three things, right? So let's see what we got. We don't have any. Oh, actually, I have this right here. I have AC is congruent to AC, but they're not giving me that one right now. So we'll give them back to that. So how do I know that these two segments are congruent? Well, I know the triangles that contain those segments are congruent, right? And so if those two triangles are congruent, then that means that those segments are congruent because they're parts of the triangle and they correspond to each other, right? AB is the first two here, AD is the first two there, so they go together. They're congruent to each other. That is CPCTC. Corresponding parts of congruent triangles are congruent to each other. So there's that. Well, now what are we going to do? Well, you know what? We can also say that those segments are congruent to each other, right? Because they're part of that big segment. And if we can get rid of those, then we'll just have AE and EF, which is for the triangle that we want. So we're going to say those are congruent. How do we know they're congruent? Well, because those triangles are congruent. And these are parts of congruent triangles. So that's what we say. We got corresponding parts of congruent triangles are congruent, CPCTC. And so now, if I said that those segments are congruent, AB and AD, and EB is congruent to FD, well, if I just subtract those two little segments from the big segments, I'll be left with AE and AF. All right, so we're just going to subtract those out. Let's see, what do we got here? Congruent segments added. There we go. Congruent segments subtracted from congruent segments form congruent segments. Because if I subtract EB and FD from AB and AD, I'll get those. Okay? Because they were all congruent to each other. It's kind of like subtracting the same thing from both sides of an equation. Okay, so how do I know that AC is congruent to AC? Well, it's the same line. So that's reflexive property. Everything's congruent to itself. Alright, so that gives me a segment, and that gives me another segment. So I've got two sides of this triangle I'm looking for. Now we're going to say this angle that we're looking for. Alright, so angle EAC and angle FAC, that will give me three pieces to the triangle. Now, how do I know that these two angles are congruent? Well, that's right. They were in the triangles, right? They're part of those big triangles. And so, since they were part of the triangles that were congruent, they're congruent to each other. That's again CPCTC. So now I have an angle, I have a side, and I have another side. And that angle is in between the sides, so we have side angle side, and I can say the triangles are congruent. There we go. Alright. Now, let's do a hard one really quick. Let's do one of these. This one isn't going to give us anything. It's just going to say, here's your stuff, solve it. So what do we got? We've got ABG is congruent to angle FEI, segment CH congruent to segment HD. Okay, those two are congruent. We're trying to prove that the triangles are congruent. Triangle BGC congruent to EID. Okay, so I know those are congruent because that was given to me. I know those segments are congruent because it was given to me. And I know those segments are congruent because it was given to me. And I want to prove these two little triangles, right? BCG and EID. So I want to prove that these two little triangles are congruent. Okay. So if I want to prove those two little triangles are congruent, right now, all I have is one set of sides, right? But I need three things. One thing isn't going to do it. I got to have three things to prove these are congruent. So what can I do? I need to get another angle. I need to get another side, something. So let's take a look at this. I always like to start with the sides. I find them easier. So do I have any other information about any of the sides? About side BG or CG? Do I have any information about sides? And no, I don't. Okay, so that means we're going to look at angles. Well, let's take a look at this. You know what? Right here, I've got a linear pair, right? And so that can tell me something because I've got a linear pair over here too. And these two angles are congruent, so I've got stuff that's got linear pairs there. So we're going to talk about those linear pairs. If you have a linear pair, that means that you have angles that are supplementary. So that's what we're going to say. We're going to say that angle ABG and angle CBG are supplementary. That's these two angles right here. How do I know that? Because they're linear pairs. Let's see. There it is. Linear pairs are supplementary. I'm going to try it. Does that work? Yeah, it does. Now we can say the same thing over here. So supplementary, that's going to, so there's those. Now we're going to say DEI, angle DEI, and angle FEI are supplementary, again, because they're a linear pair. Right there, linear pair. Now that I know that those are supplementary and those are supplementary, well, this angle and this angle, those are supplementary to two congruent angles, right? Because these two angles are the same, so whatever you subtract from 180 is going to be the same thing here, and you subtract it from 180 is going to be the same thing there. Those have to equal, so we can say that those are congruent to each other. So we've got congruent angles. We're going to say angle CBG is congruent to angle DEI. Why? Because they are both supplementary to congruent angles. So let's see something about supplementary. There we go. If two angles are supplementary to or supplements of the same angle or to congruent angles, then they are congruent. And that's what we have. Now I have a side and I've got a set of angles. I need to get another angle. Well, let's see here. Another angle because I still don't know anything about the sides at all. Okay. So let's see here. Well, they told me this. What can I do with this? Well, that makes an isosceles triangle, doesn't it? This top triangle here is isosceles. And if this top triangle is isosceles, then that means I have base angles. My base angles are going to be congruent to each other. So let's say that we're going to have angles congruent to each other. We're going to have angle, let's see this one out here is HCD. HCD. And the angle over here is HDC. HDC. Those are congruent. How do I know? Because they're base angles of an isosceles triangle. Let's see what we can find here. Base angles of an isosceles triangle. Doesn't say anything about base angles, does it? There we go. Angles opposite of congruent sides are congruent. That's what I need. So there we go. Angles opposite of congruent sides are congruent. So those angles are congruent to each other. And what can I do with that? Well, you know what? This angle is congruent to that angle. Those are vertical angles, aren't they? Yeah, those angles are vertical angles. And, oh, those angles are vertical angles. I got vertical angles. I've got congruent angles there. So we'll do that. Let's say we've got some congruent vertical angles. So that would be angle BCG. Angle BCG is congruent to angle HCD. Why? Because they're vertical angles. There you go. Vertical angles are congruent to each other. So there we go. Those are congruent. And you know what? That means these two are going to be congruent. Let's say that. So we're going to have some angle congruence there. We've got angle, let's see, what is that? BCG is congruent to this one over here, EDI. Why? Because they're congruent to congruent angles. See, that's... Oh, wait a second. We didn't say that those two are congruent. Those are vertical angles there yet, did we? Let's say those are vertical angles. So angle HDC. HDC is congruent to EDI because they are vertical angles. There we go. There we go. And look, if BCG is congruent to HCD, which is congruent to, then it's also congruent to HDC, and so it's also congruent to IDE. And that is the transitive property. If you have two things that are congruent to the same thing, then they're congruent to each other. So BCG is congruent to EDI by the transitive property. There we go. So now, do I have three sets of congruent parts inside my triangle? I do. I have an angle, I have another angle, and I have a side. And so that is going to do it. I can say my triangles are congruent now. I can say triangle, what order did they have it in? They had BCG and EID. Okay. So I could say triangle BCG is congruent to triangle EID. Why? Because I've got angle, side angle. Yeah, the side is in between the angles, so angle, side angle. Right there. It works. However, one of the vertices is not right. Which one? Oh. So, as we talked about at the beginning, they've got to match up. Angle B is congruent to angle E. Angle C is not congruent to angle I. So I've got to flip that around. Angle C is congruent to angle D, and angle G is congruent to angle I. All right, so you got to pay attention to that. Make sure you have the angles in the right order. And now it likes it. Now it's happy, and we can hit submit. There we go. All right, that one was fairly complicated, yes. So, you got to take these step by step. If you skip something, it's not going to work. All right, you got to make sure you have your angles in the right order, all of that. So, really quickly, just a couple of things just to keep in mind, little tips. Number one, don't forget reflexive property. Stuff's congruent to itself. And transitive property. If two shapes are congruent to a third shape, then they're congruent to each other. Right? If AB is congruent to CD and CD is congruent to EF, well, you know what? AB and EF are both congruent to CD, so AB and EF are congruent to each other. All right? Don't forget about vertical angles, linear pairs. Those are very useful. Base angles are congruent. So if you're looking at it on the Delta Math program there, it's opposite. Angles that are opposite congruent sides are congruent. Okay? Just another tip, if you have parallel lines, the first thing you want to look for is alternate interior angles. All right, those are the ones that show up the most. If you're not looking for congruent stuff, then if you're looking for supplementary, you want to look for same side interior angles. Occasionally you'll be looking at corresponding, but usually what you're wanting is alternate interior angles. And don't forget that perpendicular lines create right angles. Okay. Anyways, hope you found that useful, and I will see you in the next video.